Warning, this is very long video, but here you can see the content, and don't worry, there are no ads during the video. Hello, my name is Igor and you are watching my Tech Fun, and I have another Ender-3 3D printer review in this video, and this is Ender-3 S1 Pro, and this box is sent to me by Benchy in exchange for a review. Now let's talk about Ender-3 V2 and Ender-3 S1 differences. The most important differences is that S1 has that direct drive extruder, completely new, which is great if you want to print some flexible filaments, for example. It has dual Z-axis, also with the timing belt connected, so it's in synchronized even when it's powered off. It has pre-installed sear touch sensor, filament runout sensor, spring steel, which is removable and flexible, so it is very easy to remove the objects after printing. It has great cable management, and it has full-size SD card. So these are some main differences compared to the V2. Now there is so-called V2 Neo, which also have some upgrades. Two most important I will mention, that's the sear touch leveling sensor and the flexible bed. Now let's see the difference between S1 and S1 Pro. I will just mention the most important differences, and of course the most important, why would you like to buy S1 Pro instead of S1, is the printing temperature. Here the hot end can be heated up to 300 degrees Celsius and the bed to 110 degrees Celsius, compared to the S1, which according to the stock informations can be heated up to 260 degrees Celsius, but the Teflon touched the nozzle, so it is not recommended to go above 240 degrees Celsius because you will get some toxic fumes. This means with this we are limited to PLA, PETG, maybe ABS, but if you want to print some high temperature filaments like nylon or polycarbonate, in that case you will need those high temperatures, which can be produced by S1 Pro. There are a few other upgrades. For example, here this part is from plastic on extruder, but S1 Pro has the all metal extruder. It has the touch screen instead of this rotating knob and button. It has some new type textured PEI sheet, and it has insulation on the bottom of the bed. This means the using of that heating energy is much better. It will heat up faster, and the efficiency is also improved. It has some LED lights here on the top, which are used for in printing during the night, and it has a little bit redesigned base with a handle and a little bit bigger tool holder. Now S1 Pro is on the market now almost half years, and a lot of colleagues already tested those standard functions, but I want to test some other things, because if you want to use this printing of those high temperature filaments, polycarbonate, nylon and similar, probably you want to use it inside the enclosure. And I want to measure maybe the temperatures on the stepper motors. Also I want to check the ventilation on power supply. Or for example, on Ender-3 V2 we had the problem basically that the mainboard cooling fan was turned on when the part cooling fan was working. This means if you print ABS with the part cooling fan off, in that case during the complete printing inside the enclosure you don't have any cooling on the mainboard. So I would like to test these kind of things with this S1 Pro. But let's do the unboxing, assembling, and start with printing. Ender-3 S1 Pro material guide and the leveling tips. Quick installation guide. This is that touchscreen with a warning that I had to check the voltage on the power supply. And this is that metal extruder with the all metal hot end. Pre-installed sear touch. And what I have here is the needle for cleaning the nozzle, spare nozzle and some other parts, full-size SD card with USB adapter, pliers, tools and bolts for assembling. And again, some sample filament which is not on the spool, and I always warn new users, pay attention if you are using this sample filament. It may easily fall down from the spool holder, or you can have some filament jam. So I always recommend to manufacturers, even if you send only a few grams of sample filaments, put it on some kind of spool. This is part of the spool holder, and this is the second part of the spool holder with the filament sensor. Power cable with a scraper or spatula, but I hope with this flexible bed we don't need this. Tweezers will be more useful tool. This is the whole gantry, and as you can see it is quite pre-assembled. You can see the dual Z with two steppers, and also they are connected with the timing belt on the top, which is a little bit loose. It will be good to have some kind of tensioner here, but I think it will do the job. And the last element is the vase. And the box is empty. According to instructions, the first step is installing the hot end and the wire clamp, but in my case the wire clamp was already pre-installed. And now I can see this part is from metal. On S1 this is from plastic. I'm installing with these 4 M3x6 bolts. The next is installing the gantry to the base with these long M5 bolts. And to make it simpler, move the printer to the side of the desk and you can screw these bolts from the bottom. Next is installing the screen with these M4 bolts. We have prepared here these 3 holes, but it will be easier if I remove it first from the holder. It's easier when you move it to the side of the desk. And now let's install the cable and the monitor. I will remove the screen protector now, but immediately I want to check the voltage because we have this warning on this sticker. This is the back side of the printer, and I will remove this sticker first. And inside there is the switch, and in my case it is on 230 volts, which is correct because I'm in Europe. If you are in US, then you need 115 here. Now installing the spool holder, and now I notice that here we have some kind of ball bearing, so this part is rotating. It will result more smoother unrolling of the filament. Another small advantage compared to the regular S1. Not really my favorite method. I saw on Facebook group that several users broke this filament holder. I like better the solution where we can screw it on using the T-nuts here. On regular S1 I could move this spool holder on this alloy extrusion, but here it is too tight, so pay attention that you mount it in correct position. This means the center of the spool holder should be in the middle of this alloy extrusion. In my case it's a little bit to the right side. According to instruction, the wiring is the last step, and then I can start the leveling process, but I will insert one more step later. I'm starting with this 24-pin cable, and I lower a little bit the Z-axis so it's a little bit more comfortable for the work. And it will be secured with these 2 clips. On the back side it goes into this cable holder. Pay attention that it is long enough, but probably this paper is here for the reason, so I insert it here. Connecting the Z-axis stepper motors, and we have 2 of them. X-axis stepper motor and the limit switch. Connecting the filament sensor. And this is the other side of this cable, and it goes here to the base. And this is the wire for the LED, and it will get the power from this plug here. And basically the wiring was the last step according to instructions, and I could turn on the printer now. But I highly recommend you to check the timing belts and V-slot wheels. Now I already checked, my timing belts are already tight. If they are not, In that case you can use these tensioners here, but be very careful because you can very easily over tighten it using this mechanism. Now actually there is one more timing belt where I would like to see more tension. And that's this one here for the synchronizing of the Z-axis. I checked it will work fine if I rotate a little bit this one side, the other is rotating too. But if I would have a chance, then I will place a little bit more tension here. Basically, as you can see, it is very easy to DIY some solution. Even this pulley can be 3D printed, only you will need one M3 bolt with maybe some ball bearing. This is rotated, so it is not in the way of the stepper motor on the direct drive extruder. And then checking the V-slot wheels, usually they are so that we have some fixed wheels. For example, on Z-axis on one side here they are fixed, but on this side we have eccentric nut, and I can use component wrench to rotate a little bit this eccentric nut until I get the perfect tension, and I cannot rotate these wheels very easily with my hand. So on a Z-axis we have two eccentric nuts, they are here from the inside. On the X-axis there is one from the bottom, and on the Y-axis we have two. Now I already mentioned earlier that this base is redesigned, and now we have a little bit less space here for the walking. For example, it will be a little bit harder to rotate these knobs to adjust manually the bed leveling, and also it's a little bit harder to access to the eccentric nuts with this open-end wrench. You have two solutions, or you can remove completely these knobs and then you can remove this aluminum plate, or you can use something like this. This is 10mm open-end wrench, which is longer, and now I can easier access to these eccentric nuts. Well, theoretically it's assembled now, but I want to see what is inside. So this is the opening for the mainboard, and probably this is the opening for the ventilation on the power supply unit. But I have a feeling again that they covered some ventilation holes here, but I will see when I remove this plate, because don't forget, so this printer is designed to print at high temperature, usually inside the enclosure. First I thought that I only have to remove these 4 smaller bolts. I removed 4 bolts and I cannot remove the base plate. It looks like I have some tension here. I try to remove the gantry screws, but in that case this is not really comfortable to be removed. Of course, you don't have to do this, but it's just my curiosity. Basically, good news is that you don't have to remove both, only inside bolts. In that case, you can remove the plate, because there is some step hole here. Now it is better visible, so only 2 inner bolts has to be removed from the gantry. And as I predicted, so we have these ventilation holes, they are blocked by this plate here, because this is the opening for the fan. It sucks the air through these holes here, and it should go out somewhere here, but partly it is blocked by this plate. Here I will drill some holes, but of course you don't have to worry. I mean, thousands of these machines will be solved and they will work correctly. But I know from Ender-3 V2, if I do these modifications, from time to time the power supply unit will turn off the fan, because it turns on only above some temperature. And especially inside the enclosure, so it is good that we have the ventilation correctly, because this will make the lifespan of this power supply unit longer. Okay, let's see what we have here. 24 volt 60 by 60 fan. This is good because they are bigger, resulting bigger airflow and quieter. And this is the main board. I cannot see really clearly this number. It says V24S1 301 or something like that, but here you can see magnified picture. This is the slot for the regular size SD card, and big improvement compared to the V2 is that they use ferrules on high current wires. This is very important for the safety reason. And this is something I have to check, that this fan is always on, because on Ender-3 V2 it was turned on only when the part cooling fan is working. Imagine printing ABS inside the enclosure on high temperatures, and if you don't have part cooling, in that case fan on the mainboard is not rotating. So let's do some measuring. From the center, this hole is exactly on 120 millimeters, and I can see that this is exactly below this hole, and distance between these two holes is 45 millimeters approximately. Well, I hope this user manual is squared. I hate this hot glue, but now I can remove the plate. Let's plug in the fan. Well, I hope this mainboard cooling fan rotates continuously, because if not, then I have to rewire it. On the Ender-3 V2 I connected it to the hot and cooling fan, but here I'm not even sure where should I rewire it, because I cannot see that connection. Maybe directly here where 24 volts from the power supply units arrives to the mainboard. I'm not sure. I want to check the part cooling fan and the mainboard cooling fan, are they connected. So now the part cooling fan is disabled. Great, and the mainboard cooling fan is rotating, so they are not connected like on Ender-3 V2. But let's put this back together. Well, not a perfect solution, but better than nothing. And I'm placing back these 4+2 bolts. And now it is ready to be powered. But before you turn it on, again, be sure that you check the voltage on the back side of the printer. For the first filling it is quieter than Ender-3 V2, but I will measure the noise later, at the night when there are no other noise pollutions. And now the leveling process. Now in this manual it says to use the Sear Touch leveling sensor first, and it will create some offset mesh, and it will compensate anything which is out of the perfect leveled surface. Now I don't like this method because theoretically yes, it will work. Imagine if the bed is under the angle, it will create an offset mesh and it will compensate that during the printing. But the best is if I do the manual bed leveling first, and the best is if it doesn't have to compensate anything at all. If this sounds a little bit complicated, then you can check my video where I explain the manual and automatic bed leveling in 2 dimensions. It is much easier to understand. So first I will home the z-axis and move the z coordinate to 0, and then do the manual leveling process. Now the z is home, but it always raises a little bit, so I will moving the z-axis to 0. It is still too high, so I will now set the z offset somewhere. Okay, the bed is level. This means the bed is now parallel with the moving path of the nozzle. And now I can do the automatic bed leveling. If there is some inaccuracy, then it will be recorded and compensated during the printing. And this is the time lapse of approximately 3 minutes. The bed is leveled. I will home one more time the printer and check if the Z coordinate is on good place. And now if I move the Z coordinate to 0, I have that nice friction between the nozzle and the paper. Okay. Keep in mind that the PI sheet always has to be clean, so use some isopropyl alcohol before every print. Now I heat up the nozzle and insert this filament. Ready manual. Here I can see the preheat PLA settings. And I can see the PLA will be heated to 200 degrees, the nozzle, and 60 the bed. I cut the end of the filament under 45-degree angle through the sensor. And then through the hot end. I can see it was tested with some yellow filament, and this is what I always missing in the packaging kit, metallic tweezers. And for the first printing I always like to use the SD card, the G-code, which is prepared by manufacturer, because in that case if there is some problem I know that it's not cased by my slicer. I believe this is some kind of coin. I saw that on Ender-3 S1. And during the printing I'm always ready to do some settings, for example in Z offset, but this printing looks okay so far, but if it will be too close then I have to raise it, or if it is too far then lower it, but no changes here. And like on the regular S1, it is a little bit hard to find good angle for the camera, but from the side I think this is acceptable, because from the front it is covered by this part-coil fan. And what I'm missing here extremely, and that's the current Z coordinate. And it starts the bridging process now. Printing is finished in 29 minutes, let's confirm it. Quick check of the bed adhesion. Which is good, but it could be better. Probably I have to play a little bit with the Z offset. Let's analyze quickly this coin. The top surface looks very nice. From the bottom, well, this is the result of this textured surface, and I think I should lower the Z offset a little bit. And this is the bridging. This is how bridging looks like from the bottom. But it's time to prepare the slicer and slice my own object. And another nice feature I noticed, that the hot and cooling fan turn off when the hot end is below 50 degrees Celsius. And here I'm using Ultimate Care Cura, and I'm adding this printer, add node network printer, searching for the creality 3D folder. And S1 or S1 Pro is not here, I'm just adding Ender-3 Pro, and I will just rename it. And I'm replacing the Z height to 270 millimeters. And one important thing has to be changes here. This is direct drive extruder, so the retraction should be reduced to, let's say, 1 millimeters. And adding this calibration cube and slicing it and preparing the G-code. I'm still searching for the best view angle, but from left or right side is the best. And I lowered the Z offset a little bit, so I hope the bed adhesion will be better now. Printing is finishing in 35 minutes, and the bed temperature is still 51 degrees Celsius. Acceptable, but I would like to see better bed adhesion. Quality of the side surfaces is great. On the top I'm not satisfied with this quality, and on the bottom I can see that I cannot really go much lower because I can see now the texture of the bed here. But let's check the dimensions. In X direction, Y direction, quite accurate in X and Y, and let's see the Z. Wow. So basically this is very accurate calibration cube, only I have to figure out how can I improve the top surface a little bit. The next one will be the Benchy, and I will measure the bed heat up time. And in approximately 1.5 minutes it is on 60 degrees Celsius, so this is very fast thanks to the insulation on the bottom. Printing of the Benchy starts okay, but printing time will be approximately 1 hour and 15 minutes, and I want to measure the temperature of the stepper motors after 1 hour of printing. Printing at 90%. Printing is finished. Bed adhesion check. It's good now. I'll wait until it cools down and then I will remove it. Probably it will be much easier. The bed surface cooled down. Oh, and it's completely removed. Now basically this Benchy looks great. Perfect overhang, great bridging, a little bit uglier first layer. and I can see just a few very light strings there, but I know that that's the result of the bad quality filaments. So definitely, creality, I would recommend you to put some better quality filament inside on the spool with some vacuum packaging and silica gel inside. Otherwise, great printing. Seems a little bit visible, but that's always the case. Now let's see the temperatures of stepper motors. Printing of the bench is in progress, but after 45 minutes I know that the temperature on all stepper motors stabilized. I know this from my earlier experiment on Ender-3 too. I want to measure every stepper motor, and the hottest one I want to measure inside the enclosure. Probably it will be the y-axis, but let's measure them. The extruder is hardest to measure, but it is 35 degrees Celsius. X stepper motor 49 degrees Celsius. The y-axis 60 degrees Celsius. Left z-axis 40 degrees Celsius. The right z-axis 39 degrees Celsius. So as I predicted, the y-axis stepper motor has the biggest temperature because probably thanks to the VRF it gets more current because it has to move more mass. Now it will be good on the z-axis to measure not only the stepper motors but the stepper motor driver, because we have only one stepper motor driver which sends the current to two stepper motors, but I trust to that 60mm fan, so I believe the cooling of the mainboard and the stepper motor drivers is not an issue. And yes, I have a thermal camera too, but direct measuring with the contact is much more accurate. The temperature inside the enclosure is approximately 48 degrees Celsius. After approximately 54 minutes, the temperature on the y-axis stepper motor is approximately 78 degrees Celsius. Wow, that's quite hot. Still with PLA, I want to check is everything okay with the printing in spiral or vase mode, because with some printers I noticed that there is a problem if the power of sound function is on. In that case we have some pause in the printing. And this vase is from my previous video, and my wife really likes it, and another one. This is printed with everyone's dual color filament. Now I notice that here I have these breaks too, but after every maybe 10 or 20 circles, but they are still there. So I will disable this power of resound function and I will restart this printing. On Ender-3 to now I had these breaks in every circle. Here they are very rare, but I can still see those small spots, and here the nozzle stops for the moment. And now I repeat this printing with this power loss resound function turned off by adding M413 line in the G-code, and we will see if it will be better. And this time the printing is perfect, not even one small spot or breaking in the printing, but I will show you two objects side by side when it will be finished. Only I have to hope now that I don't have power loss during the printing. Pad surface cooled down. That was easy. And this is classical perfect spiral vase. Just to show you, here I can see these spots, and here I cannot see any of them. This is a small calibration cube, and with this printing I want to test M600 command for the filament change, for changing the color. Unfortunately I don't have the exact Z position on the screen, so I don't know exactly the moment when we will ask for the change, but I hope I will catch it with the camera. It says the filaments are running out, please speed up the filament or stop the printing. I will speed up this part, but you will see M600 command worked, but it was not perfect and instructions were very confusing. So this part definitely needs an improvement in the firmware. And it continued with the printing, so it doesn't work perfectly, but it worked basically. Okay, this color change was not so smooth, actually not as expected, but as a final result it worked and the color is changed. So as I mentioned, not really the smoothest color change, but it worked. it is night, so there are no other noise pollutions, and I'm measuring the noise from exactly half meter distance. Approximately 48.4 decibels, and I will measure later inside the enclosure. And I'm adding these information to my summary table on my website. And now I'm placing S1 Pro inside this small creality enclosure. But S1 Pro is a little bit wider compared to the V2, so it fits in this smallest creality enclosure, but it was a little bit hard to place it in. Now I am moving to higher temperature filaments, and I need this experiment for myself, so I have here the Titan X filament, and the printing temperature is between 240 and 265 according to the website. And I want to do two printings. First one will be on 240 degrees Celsius. Let's say you have S1 or any other older Ender-3 printer. And then I will repeat the printing on 265. I want to compare the layer adhesions. I placed the temperature sensor on Y-axis stepper motor, and I also moved the screen outside. I'm not sure if you're familiar with printing inside an enclosure. For ABS you don't need too big temperatures, but it is important when you close it, then don't open it during the printing. Probably inside will be 45 or maybe 50 degrees Celsius. And for the first printing I don't use any adhesives, only this PI sheet as it is now. If it will fail, then I will use some PI based glue stick. Printing is finished, and the temperature inside the enclosure was 47.5, 48 degrees Celsius. And immediately I want to check the bed adhesion, which is really great until it's hot, so I will wait until the surface cools down. And now reprinting everything on 265 degrees Celsius. And printing on 265 degrees Celsius is finished. And of course this is not the subject of this video, but let's measure the layer adhesions. So these objects are printed at 240 degrees Celsius. And these are 265. Well, I thought the difference will be a little bit bigger, but this is not the subject of this video anyway. But now let's print some polycarbonate. And now let's move to even higher temperatures. This is polycarbonate, well actually plus cement PC blend, and I will print everything on a high recommended printing temperature on 285 degrees Celsius. Well, the start is good, the first layer lay down, but I hope it will stay like that because probably this will start with the warping later. The printing is at 30% and it's still perfect, completely straight, no warping at all. And the printing is finished, perfectly straight. Let's check the bed adhesion, which is great. I hope not too good. I will let it to cool down. This is the brim. And I'm printing one more object from PC Blend. This one is a little bit taller, but so far absolutely no problems. It's completely straight without any warpings. And this printing is also finished, and the bed surface already cooled down. Just a minimal warping. Let's try to remove it. It is very easy because it's completely cooled down now. And this is the brim. And now the conclusions. Well, this printer is on the market now more than half years, and there are a lot of YouTube reviews, so I tried to test a little bit different things which I was curious about. And basically I have a lot of plans with this printer because I want to replace my Prusa RCS for printing those high temperature filaments, because I have some problems with Prusa. I have to reprint those extruder parts because they are from PETG and I need them properly from ABS, because inside the enclosure they start with a deform a little bit. Now it is very hard to find things for improvements with this printer, which is really great, but I have few things. For example, adding those ventilation holes or power supply units, tweezers instead of this scraper. I didn't even use it. With this flexible bed we don't need a scraper, but metallic tweezers are much more useful. Well, it would be good if it were arrived with hardened nozzle. In that case, that could use in the marketing that it is able to print, I don't know, not only polycarbonate and nylon filaments, but also carbon fiber filaments. This extruder is great, but it's a little bit too closed. So if you have to open it, if you have some clogging, it will take maybe half hours until you clean it, because it's a little bit complicated for the cleaning. I worry a little bit about that y-axis stepper motor. Almost 80 degrees Celsius, 7 to 8 in my test. If there are any experts in electronics, then I would like to see some advice. Is it too hot or what? I already tested with passive heatsink. It will reduce the temperature maybe 3 or 4 degrees Celsius on this temperature. So without active cooling fan, it doesn't help. And actually on y-axis stepper motor it's not so easy to place it because the knob is in the way, so maybe only from the side. So I'm curious about your opinion. And also I see a space for improvements with the firmware. Just few quick examples. I really miss that to see during the printing the current Z coordinate. That for me is very important. This M600 command works, but the instructions are a little bit confusing. And for example, if I change the speed in a Cura, it's not visible here. So I have some printing where I change the speed to, I don't know, 60%, few layers, and then back to 100%. But I couldn't see the effect here on the screen. So this is new firmware because this is new touchscreen here. I hope these things will be fixed and improved in future firmwares. So basically every other things are fantastic on this printer, and I highly recommend you if you want to print these high temperature filaments. Very important. If you want to print only PLA, maybe sometimes PETG, then I will recommend you the regular S1. And this one, of course, if you want to use the possibility of those high temperatures polycarbonate, high temperatures ABS, ASA filaments. Well, in this video I didn't test nylon filaments, but from Polymaker I got the whole line of the nylon filaments, mostly carbon fiber and glass fiber, and they will be tested with S1 Pro. Only I have to replace the nozzle. If you have some other comments or suggestions, write me a line in the comment sections. Thank you for watching and happy printing!